Hello and welcome back. This is Saxon Math, Lesson 56, Common Denominators. It's Part 2. In Lesson 55, we added and subtracted fractions that did not have common denominators. We renamed one of the fractions in order to add or subtract. In this lesson, we'll rename both fractions before we add or subtract. To see why this is sometimes necessary, consider the problem below. Tony and Catherine ordered a pineapple pizza. Tony ate half and Catherine ate a third. What fraction of the pizza did Tony and Catherine eat? We cannot add the fractions 1/2 and 1/3 by simply counting the number of parts because the parts are not the same size. That is, the denominators are different. So when you look at 1/2 and 1/3, you just simply can't add them together to find the equivalent fraction form. These fractions do not have common denominators. Renaming 1/2 as 2/4 in this case wouldn't help us either. In the fractions 2/4 and 1/3, the parts are still different, of different sizes. So if you had 2/4 and 1/3, it still doesn't work. Those don't have common denominators. So you must rename both fractions in order to get parts that are the same size. The least common multiple of the denominators can be used as the common denominator of the renamed fractions. The least common multiples of 2 and 3, or the denominators of 1/2 and 1/3, is 6. So the best choice would be to rename 1/2 as 3/6 and 1/3 as 2/6. Now you have an equivalent fraction of 1/2 as this and an equivalent fraction of 1/3 as this. And now that you have 3/6 and 2/6, you can add those together. And you'd end up with 5/6 as the completed amount. So if we were to transfer this amount over to here, if we added those two together, we would end up with 5/6 as the total. So let's look at 1/2 and 1/3 again. So I notice that in this case, I have to recognize that both of those are different denominators. I need them to be like denominators. So I'm going to change. If you were to just multiply the denominators together, you could get 6. So you notice that you can do that. Multiply this denominator times that denominator and vice versa, and you end up with 6. Now if I multiplied this times 3, I have to multiply this one times 3 to get 3 in the numerator. If I multiplied this one times 2, I have to multiply this one times 2 to get 2 in this one. Because remember, if I'm multiplying this one times 3, this one was times 2, this one was times 3 up here, so I have to make sure I do that. So these are equivalent fractions now. 3/6 is the same as 1/2, 2/6 is the same as 1/3. So the denominators being renamed, you would get 5/6. So how do you rename a fraction? You simply multiply it by an equivalent fraction that's equivalent to 1. So here's what we did. We multiplied 1/3 times 2/2, which got us 2/6. And we multiplied 1/2 times 3/3, which got us 3/6. What does this equal? This 3/3 is 3 divided by 3, which equals 1. 2 divided by 2 is equal to 1 as well. So when you rename a fraction, you're simply multiplying by an equivalent fraction that's equal to 1. And you can do whatever you want. As far as 1/2 could be times 100 over 100. And then the equivalent fraction of that would be 100 over 200. Notice how this is equal to 1 because 100 divided by 100 is 1. Let's look at another example. If Riza saw that she had 3/4 of a carton of 12 eggs, she used 2/3 of a whole carton to make a batch of French toast for the family. What fraction of a carton of eggs was not used? So to find the fraction that remains, we subtract 2/3 from 3/4. The least common multiple of 3 and 4 is 12. We rename both those fractions so that their denominators are 12, and then you can subtract. So if you rename 3/4 and 2/3, you would get 3/4 times 3/3, that's the equivalent to 1 there, and you'd end up with 9/12 for that one. If you wanted to rename 2/3, we multiply it by 4/4, which is also equivalent to 1, and you get 8/12. Now you can take 9 minus 8, which is 1, and the denominator remains a 12. And you can check for reasonableness by thinking about the number of eggs. If the carton holds 12 eggs, then there were 9 eggs in the carton because of 3/4 of 12 being 9. 3/4 times 12 is the same as 9. If we were to reduce this, that'd be 4 divided by 4 is 1. 12 divided by 4 is 3. 3 times 3 is 9. 1 times 1 is 1. This would equal 9. 3/4 of 12 is 9. Riza used 2/3 of 12 eggs, which is 8 eggs. Because if you were to do 2/3 times 12, again, you could reduce this one. 3 divided by 3 is 1. 12 divided by 3 is 4. 2 times 4 is 8. And 1 times 1 is 1. This would be 8 here. And then subtracting 8 from 9 leaves 1 egg in the carton, which is 1/12 of the carton when it had 12 to begin with. Renaming one or more fractions can also help us compare fractions. To compare fractions that have common denominators, we simply compare the numerators. So you know that 4 is less than 5, therefore 4/6 is less than 5/6. And this actually reduces to 2/3. So 2/3 would be less than 5/6. So to compare fractions that don't have common denominators, we just need to rename one or both of those fractions so that they do have common denominators. And because these both have 6's, we know that 4 and then 5 is all we need to compare really, and we know 4 is less than 5. Comparing 3/8 and 1/2. So first off, I need to make sure my denominators are the same. So I can recognize that I'm going to do 2 times 4 in this one, 2 times 4. And since I'm going to multiply that one times 4, I'm also going to multiply the numerator times 4 because that's an equivalent fraction to 1. So 1/2 is the same as 4/8. Now I can compare 3/8, this 3/8, and this 4/8. I can compare this 3/8 and the 4/8, and I recognize that 3 is less than 4. So you just rename the 1/2 so that the denominator is 8. So it should look like this, 4/8. 1/2 equals 4/8. And then you can see that 3 is less than 4/8. 3/8 is less than 4/8 because 3 in the numerator is less than 4 in that numerator. And that's all there is to it. Example 4, compare 2/3 and 3/4. So again, the denominators have to be the same before we can start comparing these. Unless we were using fraction manipulatives, and we're not in this case. We're going to use arithmetic. So I see that 3 and 4, the least common multiple of 3 and 4 equals 12. How do I know that? Because if the multiples of 3 are 3, 6, 9, 12, if I was to multiply those out, 4, 8, 12, 12 is the least common multiple, so I'm just going to do that. And if I do that, that means 2/3. I need an equivalent fraction with a denominator of 12 for that one. And for the 3/4, I need another equivalent fraction with a denominator of 12 for that one as well. And I should recognize that when multiplying this one times 4, I get to 12, so I have to multiply this times 4. And this one was times 3 to get to 12, so I have to multiply the numerator times 3. So now I'm comparing the numerators, this 8 and this 9. So now I have a recognition of this. I should see that 8 is less than 9. Therefore, 2/3, which is what we started with, our original problem, and 3/4, you can see that 2/3 is less than 3/4. So the original problem should look like that. The denominators 3 and 4 should be renamed to 12. and then you see your 8 is less than 9, and that would be your answer. So therefore 2/3 is less than 3/4. Okay. If you were to use your answer from example 4 to arrange these fractions in order from least to greatest, 3/4, 1/2, and 2/3, you can see that for the 3/4, that's 9/12. 2/3, we already know that because we did it up here, that's 8/12. And this one, hopefully you already know that if you're doing half of 12, because half of 12, well, 6. So if we're going to organize these in order from least to greatest, I see that 6 comes first. Therefore, 1/2 is the first of those fractions. 8 comes next, so that means 2/3 is the next one. And 9 is last, so that means 3/4 would be the final one. So from least to greatest, it's actually 1/2, 2/3, and then 3/4. Because if you were to change these in order, it'd be 6/12, and then it would be 8/12, and then it would be 9/12. And remember, this was 1/2, this was 2/3, and this was 3/4. So that's the order it would go in. All right, let's try some of these. Letter A, 2/3 minus 1/2. So let me just put letter A right here. I'm going to start with 2/3 minus 1/2. I'm going to rewrite that problem like this vertically, and then I'm going to put equal signs here. I want a common denominator of 6 the way it looks, because 6 would be the least common multiple of 2 and 3. And if I was to get from 2 to 6, I had to multiply this one times 3. That means I have to multiply this numerator times 3. This would be 3/6. This denominator I have to multiply times 2 to get to 6. So I have to multiply this numerator times 2, which would end up being 4. And now I'm subtracting these. 4/6 minus 3/6 equals 1/6. That would be the answer for that one. Letter B. So for letter B, 1/4 plus 2/5. Again, I'm rewriting this vertically. And then I just need to put equal signs like this. I need to recognize what the least common multiple is, or maybe I don't. You don't always have to have the least common multiple. You could just multiply the denominators together and get to 20. So that's what I'm going to do. I'm going to say 20. I don't even know if that's my least common multiple right now, but it might be. It's at least a multiple of both 4 and 5. If I was to list all the multiples of 4 and all the multiples of 5, 20 would be one of the common ones between the two. Now I know that 5 times 4 is what got me to 20 there, so I have to do 2 times 4 up here, which is 8. And this one was 4 times 5. So I have to do that in the numerator, 1 times 5, so there's 5. And I'm adding, so I'm going to make sure I add 5 plus 8, which makes 13. And then there'd be 20. 13/20. And that cannot be reduced, so that's the end result. Letter C, we have 3/4 minus 1/3. So I'm going to write that just like this. I'm going to do equal signs again, and I'm going to recognize, oh, it's the same, similar. I know this least common multiple was 12 of these. So I'm going to put 12 as the denominator. And then I'm going to multiply that 4 times 3. To get to 12, I have to multiply the numerator times 3 to get to 9. This denominator would be times 4 to get to 12. So I have to multiply this numerator times 4, which ends up being 4 here. And it's subtraction. I've got 9 minus 4, which equals 5. And the denominator is 12. That can't be reduced. That's my final answer for that one. All right, and then letter D, you have 2/3 plus 1/4. So I'm going to rewrite that and put equal signs there. Looks like the least common multiple is also 12 there. So let me just do that. 12 goes here. This one would be like multiplying times 4. And this would also have to be times 4 up here. And that would be 8. This one has to be times 3 to get to 12. This one has to be times 3. which should get me 3 there. So that's addition. So I have 8 plus 3, which is 11. And the denominator stays the same. It's 12. So it'd be 11/12. Letter E, if you have 1/3 minus 1/4. Again, looks like the denominator for the new renamed fractions is going to be 12. I'm going to subtract that. And it looks like I need to multiply this one times 3 to get to 12. Numerator times 3 to get to 3 here. This denominator, I have to multiply it times 4 to get to 12. I have to multiply the numerator times 4 to get to 4. Now I have 4 minus 3, in this case, would be 1, and the denominator stays the same, 12. All right, and then letter F, 1/2 minus 1/10. So I'm going to rewrite those vertically like that, and I see, oh, wait a minute, I don't have to change this 1/10. That's just going to stay the same because I have a common multiple here. I can multiply this one times 5 to get to 10 over here, and I have to multiply that times 5 in the numerator. So I'd have 5/10 is the same as 1/2, and I have 5 minus 1 here, which equals 4. This would be 10, but I have to see that, okay, I have to reduce. So this, both of these are divisible by 2. This would be 2/5. So my final answer for letter F should be 2/5. All right, let's try some more. Before comparing, write each pair of fractions with common denominators. So for letter G, they want us to rewrite 2/3 and 1/2 as fractions with common denominators. So I'm going to write 2/3. It looks like 6 is going to be my denominator for both of those. 2/3, 6. So this would be times 2. So that one's times 2. This would be 4 up here. This one is times 3. So this one has to be times 3. That would be 3 there. Now comparing 2/3. All right. So keep in mind this is like together, and these are together. 1/2 is the same as 3/6, and 2/3 is the same as 4/6. I see that 4 is greater than 6. So that means, or sorry, 3. 4 is greater than 3. So when we have the denominator of 6. So now I know that 2/3 is greater than 1/2. All right, letter H. So when I'm redoing letter H, let me just rewrite those. That's 4/6. It equals something with the denominator I'm not sure of yet. And then 3/4, also equivalent fraction. It looks to me like if I was to count by 4s, I'd get to 12, and counting by 6s, I'd also get to 12. So I'm going to use 12. 12 for both the denominators. 6 times 2 would get me to 12. So 4 times 2 gets me to 8. So that means that one would be 8. This would be times 3. This one also be times 3. So I'd have 9 there. Okay, so I have 8/12 compared to 9/12. Hopefully you can see that 8/12 is less than 9/12. Therefore, 4/6 is less than 3/4 because I just kept them in that same order. And letter I, this one is 2/3. That equals something. And then 3/5, that also equals something. Looks like if I was counting by 3s, multiples of 3, I'd get to 15. I like that one. This one, multiples of 5, counting would get me to 15. So now I know that 3 times 5 is 15, 2 times 5 is 10. 5 times 3 gets me to 15, so I have to take 3 times 3 up here to get to 9, sorry. And now I have these to compare. I have 10/15 and 9/15. I need to compare the ones that have the same denominators. Remember, that's what we're doing here. That's why we converted those into like fractions or equivalent fractions with like denominators. So I'm looking at 10/15 and 9/15. I can see that 10/15 is greater than 9/15. Therefore, 2/3 is greater than 3/5. 2/3 is greater than 3/5. All right, that's it for today. Nice job. If you missed anything, make sure you rewind, rewatch, and relearn, and we'll see you next time.